Hello everyone, welcome to my calculus lecture. In this lecture, we study examples of non-existing limits. In my previous lecture, I mentioned the limit of a function does not necessarily exist. So the question is, when does a limit fail to exist? A limit fails to exist if at least one of the one-sided limits does not exist, or both one-sided limits exist, but they are not the same. So let us take a look at the following example. Uh, so here our function is defined by sine 1 over x for obviously x not equal to 0. So what you are looking at in the following figure is the graph of this function f of x equals sine 1 over x. Uh, so you see that as x approaches 0 from the left side or right side, right? You see that the graph keeps oscillating, right? The graph keeps oscillating, around 0, okay? But from this picture, you see that the graph doesn't appear to be going anywhere. It just keeps oscillating, right? It keeps oscillating. So in fact, in this case, neither the left-hand limit of sine of 1 over x when x at x equals 0, nor the right-hand limit, okay, of the same function at x equals 0 exist, okay? Therefore, in this case, the limit does not exist, all right? So, neither of them does exist. Here's another example. So here f of x is defined by the following branch function, okay? So the branch point is x equals 2. When x is less than 2, it is defined to be x minus 1. And when x is greater than or equal to 2, it is defined by the parabola x minus 2 squared plus 3. So here's the graph, all right? So when x is less than 2, it is defined by the straight line, right? X minus 1. And as you see, in this case, when x equals 2, you see like what? Little white circle, okay, which indicates that x equals 2 is not included there, right? On the other hand, when x is greater than or equal to 2, right, the graph, the function is defined by this parabola, okay, which is x minus 2 squared plus 3. So let us calculate the limit, right? The limit at so when x approaches to number 2, right? F of x, right? From the left side. So this is the left-hand limit, okay? Earlier, from the definition of this function f of x, right? When x is less than 2, remember this left-hand limit means that x is approaching to 2 from the below, okay? From below the number 2, right? Or, the x is actually less than 2, but are getting close to 2. So x is less than 2, right? Remember that. So since x is less than 2, in this case, f of x becomes what? X minus 1. So that's the function we have to use. Right, so we replace in this case f of x by x minus 1. So limit x goes to 2, x approaches to x minus 1. What happens then? When x approaches to 2, x minus 1, right? It gets closer and closer to 2 minus 1, which is 1. Okay, so we get left-hand limit 1. On the other hand, the right-hand limit, so in this case, x is approaching to 2 from above, right? In other words, x is getting close to 2, but those x values are greater than 2. So x is greater than 2, so the f of x should be replaced by x minus 2 squared plus 3 by the definition. Okay, so in this case, when x approaches to the number 2, right? So 2 minus 2 equals 0 plus 3. So the limit, in this case, right-hand limit becomes 3. So both the left-hand limit and the right-hand limit exist, but they are not equal to each other. Therefore, the limit of f of x when x approaches 2 does not exist, right? Does not exist. Here's another example. So let us evaluate limit of the function absolute value of x minus 2 over x minus 2 when x approaches to 2. Okay, right. So for the calculation, I'm going to switch to my notepad. So here we have limit x approaches to absolute value of x minus 2 divided by x minus 2. Okay, so before we continue, right, let's see what happens when x approaches 2. What happens to the numerator and the denominator? Okay, we did that before. So in this case, obviously, when x approaches the number 2, right, the numerator gets closer to 0. The bottom part also gets closer to 0. So we have 1, 0 over 0. Now, although we are calling it 0 over 0, these are not numbers, right? These are infinitesimals. Okay, so this is a 0 over 0 type indeterminate form, right? We briefly talked about this last time. Okay, so how do you calculate this? Uh, if you recall the example we went over, right, last time, we could evaluate this type of limit, by factoring, right? In this case, that's not an option because, how do we factor like absolute value of x minus 2? Okay, so in this case, actually, this limit can be calculated by using the definition of the absolute value. Okay, so to do so, we will have to first separate, right? Separately calculate the right-hand limit and the left-hand limit of this, at the number x equals 2. So first, let us talk about the left-hand limit. So left-hand limit, when x approaches 2 from the left, right? So we put negative sign there. The absolute value of x minus 2 over x minus 2. So let's see what happens to this value. Okay, first, as you can see, right, so by definition, x is approaching 2, the number 2, from the left, right, which means that x is less than 2. So here, let me put sort of note, okay, to myself and to yourself as well. So x is less than 2. When x is less than 2, okay, when x is less than when x is less than 2, what happens? X minus 2 is less than 0, right? X minus 2 is less than 0. Okay, so x minus 2. When x is less than 2, x minus 2 is less than 0. If x is less than x minus 2 is still less than 0, what happens to absolute value of x minus 2? Remember, what absolute value does is, right? Okay, is that no matter what the number goes in, it becomes positive. So how do you make it positive? Okay, often like students have no problem with this. Like I say, whenever I ask a student, so what's the absolute value of negative 2? No problem. They will say 2. Okay, and what is the absolute value of 3? Okay, that's 3, right? But if I ask, so absolute value of x, right? If x is greater than or equal to 0, what would be absolute value of x? No problem. It's going to be just x. And if x is less than negative 1, what would that be? So this is where, like, the students often gets confused, right? When I ask, what would that be? And the answer is negative x. And then this is where, they get sometimes like seriously confused. You know, because when you look at this, you focus on this negative sign. So, this whole thing appears to be a negative number. Okay? Hey, so professor, that's wrong, Um, I mean, don't you know the definition of absolute value? It has to be positive, right? But what they don't notice is that x is already negative number in this case, right? So the appearance might fool you. This looks like a negative number, but actually overall it is a positive number because x itself is a negative number. So this additional negative sign neutralize it. It becomes uh, positive. Okay. Right. So, the when we say, the definition, like, the worthy definition is just the absolute value. Actually, that's not a definition, but that's what the action by, resulted by the absolute value. Uh, no matter what the number goes in, it becomes positive. Okay, so how does that happen? It's not just magic or by simply like removing negative sign you make it positive. That kind of thing is not a mathematical procedure. Okay, mathematical procedure. So mathematical procedure, the most fundamental mathematical procedure is like adding, subtracting, like multiplying, uh, or dividing, okay, a number by another number. So this can be done when you say, we make any number, say, positive. So if it is negative number, you can make it positive by multiplying negative 2 by negative 1. Okay, that's mathematical procedure. So that's what happens here, right? So in this case also, so the absolute value of x minus 2. Now we know that x minus 2 is a negative number, right? So how do we make it positive? You multiply by negative sign. Okay, so multiply x minus 2 by negative sign, negative 1. Okay, that's what happens. So going back to our calculation of this left-hand limit, so we have a limit x approaches number 2 from the left side, right? Absolute value of x minus 2 turns into negative x minus 2 over x minus 2. So here's also another thing you will have to remember. When we say x approaches the number 2, x approaches the number 2, x is never equal to number 2. Again, the analogy I used the last time, okay, just imagine an arrow, flying arrow, heading toward a target. So it gets closer and closer to the target, but it never reaches the target, okay, right? So x is never equal to 2. So x minus 2 is never equal to 0. As long as this is not equal to 0, we can divide, right? We can divide. So x minus 2, this can be cancelled. The cancelling means that we can divide top and bottom by x minus 2, the same number, right? Leaving, in this case, only negative 1, right? So we have a limit of negative 1 when x approaches to number 2 from the left side, but negative 1 is a constant number, so whether x goes to 2, goes to 3, goes to 10 million, it doesn't matter. It's not affected. Constant number never changes, right? So, it stays as a negative 1. Okay? Right. So now let's move to the right-hand limit. Okay, so in this case, the right-hand limit of the absolute value of x minus 2 over x minus 2 when x approaches 2 from the right side, right? So we do the same game. In this case, x is greater than 2, x minus 2 is greater than 0. So the absolute value of x minus 2 is going to be, right, just x minus 2. Because, x minus 2 is positive, right? So going back to our limit, so limit x approaches 2 from the right side, right? Absolute value of x minus 2 turns into just x minus 2 over same thing, x minus 2. So this becomes 1 by the same argument, right? In case of limit, this is never equal to 2. X minus 2 is never equal to 2, never equal to 0, right? Because x is never equal to 2, right? So we can divide top and bottom by x minus 2, resulting 1, all right? The whole thing, 1. So here, the left-hand limit and the right-hand limit both exist as negative 1 and 1 respectively, right? So they both exist, but they do not coincide. They are not the same. Since the left-hand limit And the right-hand limit are not the same, okay, are not the same. What's the conclusion? The limit does not exist. Okay, so limit of absolute value of x minus 2 over x minus 2 when x approaches 2 does not exist. Okay, does not exist. Okay, so more details about my discussion in this lecture can be found in my lecture note at the following address. Okay, again, you don't have to, copy or paste, this address because this is hypertexted. So all you have to do is just locate your cursor here and then click on it. Okay, so it'll take you there. And also, if you like to visit the main blogger site of mine, all you have to do is just click on this blogger. It is hypertexted, so it'll take you there as well. Okay, so thank you for listening, watching, and goodbye.